Alright, today is our last lecture of flipping the classroom for the chapter. This is our last one. Yesterday we learned about, or actually last Thursday we watched arithmetic sequences. But this time we're going to do geometric sequences. So let's once again look at the objectives. We can determine if a sequence is geometric, like we determined if it was arithmetic. Then we had to write a rule, and then finally we found the sum. So let's think about what the difference between a geometric and an arithmetic. Arithmetic, we had a common difference. So that means that we added or subtracted from the previous term. For geometric, all we're going to do is multiply or divide. So we're going to have a common ratio. So right here is a ratio. So that could be either a fraction or a number. So let's just try some so we could get to see. So what we did, like we did in arithmetic, we took the second one and we subtracted the first. However, what we're going to do in this case, we're going to take the second term and we're going to put it over the first term. So when we simplify, this gives us 5/2. Then what we're going to do is we're going to take the third term, take 18, and put it over the second term, which is 10. This is an 8. Now let's simplify. That gives us 9/5. Is 9/5 equal to 5/2? No. We could stop there. As long as we get two that are not alike, then we say no, it is not geometric. So in this case we're making a ratio. So we're taking the second term, putting it over the first, third over the second, fourth over the third. So let's try this one. Let's take 125, which is the second term, put it over the first, which is 625. When we simplify, we get 1/5. Now take the third. So we have 25 over 125. Simplify. We get 1/5. These are congruent, so this is good. They're the exact same. However, we're not done. We have to try all of the terms. So now the next term is 5. So we do 5/25. That equals 1/5. Good, they're all looking similar. However, we have to try the last term. Do not stop until all the terms are tried. 1/5 equals 1/5. All of these are similar. So therefore, yes, it is geometric. Alright, so that is how we determine if it is geometric. We set the second over the first, the third over the second, the fourth over the third, and set to see if we have a common ratio, meaning that all of them are the same. In this case, they were all 1/5. Alright, let's move on to our next objective. Our next objective is to write a rule. So like we had the arithmetic sequence formula, now we have a geometric. This is the geometric. We have a to the n, whatever term we are looking for. We have the first term multiplied by the common ratio, then raised to the n-1. So we looking for the term. We have the first term multiplied by the common ratio raised to the n-1. So in this case, our first term is 3. That is why we have 3 right out in front. Common ratio is 2. That's why 2 is in parentheses. We're raising the 2 to the n-1. So here is a sequence that is given to us. First, let's find the common ratio. And how we're going to do that? Just like we were looking to see if they were geometric, the common ratio is the second term over the first. You could do the third term over the second, or the fourth over the third. They all will give you the same common ratio. So in this case, I'm doing 20 over 4, and I get 5. So my common ratio is 5. Then, now we just plug it in. So we have a to the n equals, what is my first term? 4. So I'm going to use 4 times my common ratio, which is 5, raised to the n-1. This would be my formula. That would be my rule. Then it says give you the next term. So we found the first 1, 2, 3, 4. So now we're going to find a to the 5th. So all we do, keep our formula. Wherever we see an n, we plug in that 5. So when we simplify, so this is 4 times 5 to the 4th. Multiply that all together. Plug it in your calculators. I don't think you guys can do it all in your head. It's a little tricky. So a to the 5th equals 2,500. This would be the next term in our sequence. Alright, so pause the video, try the next one on your own. Remember, here is the formula. A to the n equals a to the first term times the common ratio to the n minus 1. So, number 1, find the common difference. Take the second term, negative 76, over the first term, 152. We get negative 1/2. So our common ratio is negative 1/2. Do not lose the negative. The negative has to stay. This whole thing is the common ratio. Plug it back into the formula. A sub n, our first term, is 152. Then I like to use parentheses, so I make sure that the negative is raised as well, because sometimes if it's an even exponent, the negative will cancel. So don't forget to keep the negative. Then we do it to the n minus 1. This would be our rule. So it's given the first term, find the common ratio, plug it in. Let's find the next term in the sequence. So we have 1, 2, 3, 4. So we are looking for a to the 5th. What do? I keep the formula, or the rule, however you want to say it. Wherever I see n, I plug in 5. So 5 minus 1. So that will be negative 1/2 to the 4th. Plug it in your calculator. A to the 5th gives me 9.5. This would be our next term in our sequence. So this is when we are given our sequence. Find the common ratio. If you already have the first term, plug it in the formula. Find the next term. Bring questions, comments, concerns, but we're going to move on to the next objective. We're still writing a rule. However, we are given our common ratio, but we're given a different term. We are not given the first term. So, like our arithmetic, we are going to solve for A1. So the first step is solve for A1. I'm going to rewrite my formula up here. A to the n equals a to the first term. We need to find that. We have our common ratio, n minus 1. Alright, so how are we going to do this? We can write an equation for this. We have 12 equals, well, we are looking for A1. We don't know what it is. Then our common ratio is 2 raised to the n minus 1. So we have 4 minus 1. So that is just 4 to the third, or 2 to the third, which will give me 8. So I have 8 A1 equals 12. What are we going to do? We want to get A1 all by itself. Well, just treat it like an x. So we're going to divide by 8. When we divide by 8, A1 equals 1.5. So now we have our first term and we have a common ratio. What do? Plug it back into the formula. So a to the n equals A1 we found is 1.5. Our common ratio is 2. We are going to raise it to the n minus 1. This would be my rule. Alright, pause the video. Try the second one. When you have it, hit play again. I'm just going to keep going. Alright, first step. Solve for A1. I'm going to write out. So my a to the 5th is 54. That equals, I want to find A1. I do not know what it is. Times my common ratio, which is 3, raised to the n, which is 5, minus 1. So this is 3 to the 4th. 3 to the 4th gives me 81. So I have 81A1 equals 54. Treat it like an x. Divide by 81. A1 gives me 2/3. Now, once again, plug it back in. We're doing a lot of plugging and chugging in this chapter. So we have a to the n, my first term, 2/3. My common ratio, it is given 3. So bring the 3 down. 3 raised to the n minus 1. And this would be our rule. Remember, memorize this. Alright, like the arithmetic, our last one is when they give us 2 numbers in the sequence. 2 of the terms. They might not be consecutive, it might not be A1, but it will be 2. It'll give you that it's a geometric sequence. So, right off the bat, first we're going to find the common ratio. And how we do this, we are going to set up this, write out the equation first. So I'm going to write the equation at the top, a to the n equals, we want our first term multiplied by our common ratio raised to the n minus 1. So let's write out what we have so far. A to the n, we're going to use negative 12, equals, we don't know our first term. Then, we're going to we don't know r, so I'm going to keep it r. Now I'm going to raise it to the 2 minus 1. Well, 2 minus 1 is just r. So I have negative 12 equals a1 r. How would I get a1 by itself? Well, like the other ones, we're just going to divide by r. Therefore, I have a1 equals, I have negative 12 over r. So here is my a1. I know it still has an r in it, but that is okay. Now what we are going to do is we are going to plug it into the second equation that we can make. So we can make negative 3 equals, because that's, so we have a1, let's just write out how it would be, times r to the, what, 4 minus 1. So let's simplify. So let's plug in a1 over here. So we have negative 3 equals negative 12 over r times r to the third. Well, we have an r to the third on top and 1 on the bottom. We can simplify that, right? So let's simplify further. So we get negative 3 equals negative 12. If I have 3 on top and 1 on the bottom, I am left with 2 on the top. Remember, we did this before. We did this in the last chapter, solving for r's. So now, what do? Divide by negative 12. So I get a negative and a negative gives me a positive. So I have positive 1/4 equals, then what I'm going to do, I still have r squared over here. How do I get it to be unsquared? I take the square root. But when you take the square root, remember, you need plus or minus. So when it is plus or minus, well, square root of 1/4 just gives you 1/2. So I have plus or minus 1/2. Alright, now we have our r and we have our a1. So what do? Let's first find what our a1, because this is still in terms of r. So now we plug this back in here. So we have a1 equals negative 12 over, but you got to do plus and minus. So plus or minus 1/2. So we have a1 equals, if we do the plus first, negative 12 over positive 1/2, we get a negative 24. If we do a1 and we do the negative, so then we have negative 12 divided by negative 1/2, we get a positive 24. So we have 2 a1s. Alright, now we have our ratio and our a1. Make sure the ratio and the a1s coincide with each other. So now our last step is to plug it back in. So when we plug it in, our first one, a1, we are going to use the positive terms. So we're going to use this one, we use, to get a1, we use the positive. So we have negative 24, sorry, that should be an n, negative 24 times the ratio, we use the positive 1/2, raised to the n minus 1. Now we're going to use when we use the negative r. So we're going to use the second a1. So a to the n equals, well, we're going to use our positive term now. So 24. When we got the positive a1, we use the negative r. And that is still raised to the n minus 1. These two would be our final formulas. Alright, pause it, try the next one on your own, but I'm going to keep going. Hit play when you're ready again. So first thing, we need to find the ratio. So let's set negative 48 equals a1, we don't have a1, times our r, we don't have our common ratio, raised to the 3 minus 1 would give me 2. Alright, when I divide by r squared, so I get a1 equals negative 48 divided by r squared. Next thing, plug it into the next equation. So let's first make an equation with this a to the 6th. So we have 3072 equals a1 times our ratio, but now we're going to do it 6 minus 1, so this would be r to the 5th. Now plug in a1. So we have 3072 equals, we're going to plug in negative 48 over r squared times r to the 5th. Let's simplify this. If we have 5 on top, 2 on bottom, we are left with how many on the top? 3. Hopefully you guys all said that. So 3072 equals negative 48 times r to the 3rd. Alright, let's divide by negative 48. When we divide by negative 48, we get negative 64 equals r cubed. How do we get rid of a cube? Hopefully you guys are all saying, cube root it. However, is 3 even or add? It is add. So we do not need to do plus or minus. We only need to do plus or minus because this 2 was even. So when it's 2, 4, 6, 8, then you need the plus or minus. However, since it's 3, we don't need this. But since the 64 is negative, we keep our r to be negative. So we get r equals negative 4. So now we have our r. Let's plug it back in. So we have a1 equals negative 48 over negative 4 squared. But what happens when the negative 4 is squared? Well, it becomes positive. So we do negative 48 divided by 16. So our a1 equals negative 3. That is why it is still negative. Now we have our a1 and our r. Last thing, plug and chug. Plug in. Here's the formula. Don't forget it. So we need a to the n equals, what's our first term? Negative 3. What is our common ratio? Put it in parentheses so you don't forget to do the negative. Negative 4. I know a lot of you guys mess up on little negatives like that, so don't forget them. Please don't. Then n minus 1. So our final formula is a to the n equals negative 3, because that's our first term, times negative 4 raised to the n minus 1. I like putting around parentheses. Finally, we're almost there. Our last objective. We need to find the sum. So we have our formula for the arithmetic. We're also going to have one for the geometric. Oh, look right here. We need the first term. So before it was just n. However, now we need the first term times, in parentheses, 1 minus the common ratio raised to the n over 1 minus the common ratio. And notice, we can't divide by 0, so r cannot be 1 in this case. Alright, we do not have the first term. So, that would be the first thing we plug in. However, we can find it, right? Well, we start with I equals 1, so let's find a to the 1. Well, let's just plug in 1 wherever we see I. So we have 4, 3, to the 1 minus 1. Wow, 1 minus 1 is 0. Anything raised to the 0 just gives me 1. So I have 4 times 1, which will give me 4. Now, their formula is a to the n equals our first term times the common ratio raised to the n minus 1. Well, if you don't want to do all this work, you could just look. Well, obviously I would know 4 would be my first number. Then my common ratio is going to be 3, because it's raised to the n minus 1. But look, you have to make sure that it's when you start at 1. So our common ratio is 3. So let's put in our formula. We're going from 1 to 16, so we're looking for the sum of 16. So we're going to take our first term, which is 4, multiply it by 1 minus our common ratio, which is 3, raised to the n, which our n is 16. If you notice, the n here corresponds to the n up here. So 3 to the 16 all over 1 minus our common ratio, which is 3. Plug it in your calculator. When you plug it in your calculator, you get 8, 6, 0, 9, 3, 4, 4, 0. Alright, so that is 86,093,440. If you have problems with the calculator, write it down on the summary sheet and I'll help you guys tomorrow. Then, obviously you guys all know how to do it in your calculator. So, or use your calculator. Sorry, I messed up on that one. I spelled calculator wrong. So use your calculator. When you plug it into your calculator, we get, what do we get? We get 665 over 8, or when we round that to the decimal, we get 83.125. Either one of those work. Remember, you hit math, 0. Type it in. Make sure you have your lower bound, your upper bound, and your equation. Once you are done typing it in, hit enter. You should arrive at these. If you don't, that is why I have the next sheet, which is a summary sheet. Tell me what you learned. What was hard? Because we could fix it tomorrow. We could learn more. Then your objective. Can you determine if it is a sequence or not? A geometric one. So, does it have a common ratio? If yes, you think you could do it, type in a 5. No would be a 1. Write the rule. Are you good at it? Can you find the sum? If you have calculator problems, put it here. Any other questions, comments, or concerns, let me know. Alright, have a great rest of the day. Thanks.